Hi guys, welcome back to Gurutech networking training. In this video, we are going to do our advanced enterprise networking project 13, which is a secure company network design and implementation. Okay, all right. So before we start, I plead with everyone who is joining me today. Remember, this is a very important video. It's going to be a very long video. The first thing that you'll do for me, a favor actually, please subscribe to this channel, like this video, and share. The same way we're putting much effort, we're spending a lot of time and hours recording these projects, editing them, and delivering them into a more effective way through which you can learn and gain some skills. Please ensure you hit on the subscribe button, just like the video, and say something on the comment section. All right? Okay. So without further ado, let's get into business. All right. So secure company network design and implementation. Actually, guys, this is just an extension of one of the projects that we previously recorded, and it was our project 6. So if you're new here today, just know that we've been doing enterprise networking projects from project 1, and today we're doing project 13, meaning we've done 12 projects that maybe you've not seen. Please, I'll show you how to get the projects. Just go to YouTube and search our channel, actually, Gurutech Networking Training. And the first thing that you do, ensure you subscribe. Please support us. After you subscribe, just go under playlists. After you've gone to playlist, and then if you go to playlist, then you can just scroll till under playlist. You just scroll till real world networking projects, okay, or this one, enterprise networking projects. So when you click on that playlist, actually, you're going to receive a lot of projects. You're going to see a lot of projects here. Actually, you're going to see a lot of projects here that you've recorded all along, right? Okay, so you can start from the project 1, watch till the 12th project, because these projects actually were designed in a way that the complexity of the protocols or the knowledge being executed increases as the number of projects increases. So the complexity of project 1 is different with the complexity of project 2. And the same way, complexity of project 13 is different from the complexity of project 12. This shows that a new version of project is a little bit advanced than the previous one. Okay, all right. So I wish you all the best, and I believe that you're going to gain a lot regarding the enterprise network design and implementation. Also, a number of students or viewers all normally require the packet tracer files, maybe the one that I'm recording today. So to get the packet tracer file, actually, it's very simple, because you just need to join the channel membership. Well, we record the video for free, because in the entire YouTube, it's only Gurutech Networking Training that records projects from scratch. So we also require further support. Please just join the channel membership. It's not that much to pay for, actually. See the amount, $1.49. Yeah, but the knowledge you get is much higher than that, right? Okay. All right. So if you want to get the packet tracer file of any project, just join the channel membership. And before you join the channel membership, watch this video, right? Okay. All right. So let's go back to our packet tracer file. Let's go. Let me just go back to our channel and show you something. Yeah. So in the Gurutech networking training, there's a video by the name, the first video here, company network design and implementation. So this is the video that we're actually going to expand and make it look more professional. Okay. All right. So it was recorded 1 year ago, actually, and it has 130 views. Okay. All right. So I'll just minimize this and open this for picture here. Yeah. So this is the project that we're going to modify and make it look advanced actually. So in this project, as you can see, we had two ISPs. Okay, then the ISP connects to the routers. So these were the first modifications. The first modification will actually come in. Instead of the routers, we're going to use firewalls. Okay. Yeah. Then the multi-layer switch will stay the way they are. The access layer switches will stay the way they are. Then when you come to access points, the wireless access points here, we are going to use wireless LAN controller. And these access points we are going to be a lightweight access point managed by the wireless LAN controller. And we are also going to add IP phones in this setup. All right. And in this setup, we're going to have, because we have a firewall, we're going to have zones. The DMZ zone connected to the firewall where the servers are going to be located. The inside zone where the users are, and the outside zones where the clients are. All right. It's going to be a very advanced project. Okay. So I just ask for your patience because these types of videos normally takes a lot of time, maybe 3 hours. Okay. But it's worth it. Just dedicate your time, watch the video to the fullest, and you'll learn a lot. Yeah. All right. So I'll just minimize this and open the case study. Secure company network design and implementation. So in the recent time actually, I've been recording projects to appreciate the countries that that watch me the most. Yeah, so I'm mostly watching India, then the USA, then currently it's my country, Kenya. So today I'm home, actually. Today I'm going to acknowledge my country, Kenya. Yeah, I'm going to record a project to appreciate my countrymen and women for their support. Yeah. So, Advanced Enterprise Networking Project 13. Design and implementation of a secure company network system. Saturn Innovation Limited is a dynamic and forward-thinking company specializing in providing innovative cloud solutions to clients worldwide. Leveraging cutting-edge technology and a team of highly skilled professionals, Saturn Innovation focuses on developing and implementing cloud-based solutions tailored to meet the evolving needs of businesses across various industries. With a strong emphasis on creativity, agility, and customer centricity, Saturn Innovation aims to empower organizations to enhance their operational efficiency, scalability, and competitiveness in today's digital landscape. With a, work, with a workforce of 600 staff, Saturn Innovation Limited recently expanded and is preparing to move to a new building. The new building, comprising 3 floors, will house various departments, including sales and marketing, human resource and logistics, finance and accounts, administrators and public relations, ICT, and so on. The ICT department further hosts software developers, cloud engineers, cybersecurity engineers, network engineers, system administrators, IT support specialists, business analysts, and project managers. Prior to the move, a new network service needs to be designed and implemented in the new building. To ensure robust security, Saturn will implement several security measures to protect the network from internal and external attacks. The will have outside, inside, and the DMZ security zones, the essential servers strategically hosted within the fortified zone. Additionally, Active Directory Storage Server responsible for managing and authenticating users, computers, and resources within the internal network will be placed on the inside zone of the firewall. This implies that the servers such as DHCP, DNS, Radius will all be on the inside zone, while other servers such as FTP, web, email, app, and NAS storage will be located in the DMZ. The zone can be attached to any firewall as of now. This meticulous planning and deployment of security measures will safeguard the network and ensure smooth operation for certain innovation limited in its new building. Yeah. So as an integral part of our city infrastructure, the following components have been incorporated. Internet service provider. The company, actually, that should be the company. The company has established a subscription with the two ISPs, Seacom and Safaricom, to ensure redundant internet connectivity. Network security. Two ASA firewall, Cisco ASA firewall, have been deployed to enhance network security and redundancy. Network routing. Both the firewall and the core switches will be used instead of the router. Network switching. The network includes two catalysts two catalysts 3850, 48 port switches, and a catalyst this one, 48 port switches to ensure robust local network connectivity. Server hardware and virtualization. Two physical servers will be utilized for virtualization through hypervisor to achieve multiple virtual machines for various services. Wireless infrastructure. A Cisco wireless LAN controller and various lightweight access points will centralize the management of wireless network. VoIP. A Cisco voice gateway will be used to enable telephone service in the network. Cloud computing as an important technology is used to connect clients across the world to the company services and resources. Thus, the proposed network should allow the team to access the resources. Alright, therefore, as a key member of the network team, you've been tasked to design a network for the new building. At this stage, the local design is required, which shows the measures that you would put in place to ensure that the new network meets the current business needs and is future proofed. Good. So let's go to requirement. Let's go to the requirement now. Yeah. So the requirements. The company places a strong emphasis on the achieving top-tier performance, redundancy, scalability, and availability within its network infrastructure. As such, your task involves creating a comprehensive network design and executing its implementation. To facilitate this endeavor, the company has designated specific IP address ranges. Yeah. So you're going to have a management network, having that one. You're going to have a VLAN, having that one. We're going to have a LAN, that one. VoIP, that one. DMZ, that one. Public IP addresses, that one. So let's go to technical requirements now. Technical requirements. Utilize Cisco Packet Tracer as a design tool. Let's embrace hierarchical network design. ISP, we're going to have two ISP. Yeah. Then we're going to have a wireless LAN controller to manage the lightweight access points. Okay. We're going to have how many VLANs? We're going to have 4 VLAN, 10 for management, 20 for LAN, 50 for VLAN, 70 for VoIP, and 199 for black hole, in which all unused ports are placed. Then we go to EtherChannel. You're going to aggregate links to form one logical channel telephony service. We're going to configure VoIP on the voice gateway and allocate dial numbers in the format of 4 ... STP, portfast, and BP We're going to use this one to fasten or to expedite port transition from blocking to forwarding states. Subnetting is very important. We're going to do subnetting actually to allocate appropriate IP addresses to the to each group. Yeah. A basic configuration, very important. We're going to be doing all this basic configuration. In the VLAN routing, it's very important. We're going to do VLAN routing to enable VLANs to communicate. Then the core switch, we don't have a router. So the core switch will be used for switching and routing. So we need to assign it IP address, okay? So the DHCP server will be used to allocate dynamic IP address to the hosts, to our computers in the network. All right, HSRP, very important. HSRP, it's a high availability router protocol, okay? All right, so that's going to be implemented. Static IP addressing, you're going to do static IP addressing to the servers, okay? Routing protocol, well, we normally use OSPF as our routing protocol because OSPF is one of the standard and the best routing protocol, dynamic routing protocol, okay? All right, so we can't, I don't want to use EIGRP because EIGRP is normally a Cisco proprietary. I don't want to use RIP because OSPF is way much better than RIP, okay? All right, and maybe BGP, will use BGP in the next projects when you're going to do ISP networks, okay? All right, but as per now, we're going to use OSPF. Standard ACL for SSH. Remember, we have management network. So to manage the devices, we're going to do SSH, and we're going to limit only certain people to SSH on those devices. That's why we're going to do standard access control list for SSH. Cisco Firewall, very important. We're going to do a lot of configuration on the Cisco Firewall, yeah? Then the final stage is testing to ensure that whatever we configured is actually working. All right. So guys, basically, when I analyzed this case study, I realized that the company actually wants to move to a new building, and they want to design a new network to support the users actually. And there's some key points that come to me actually. We have two firewalls, right? Okay. Then there was something mentioned here, the DMZ zone. For the first time, we're not going to put DHCP, DNS, and the radius server on the DMZ zone. Why? Because the DHCP, the Active Directory server here will act as our DHCP server. But the Active Directory server, it's always a good practice to put the Active Directory server in the inside zone because it is the Active Directory server that will be used for managing and authenticating users, computers, and resources. So for the DHCP, DNS, and radius servers, you're going to put them in the inside zone, but the rest of servers, they're going to be on them. Sorry. For the DHCP, DNS, and radius, we're going to put them in the inside zone, but the rest of the servers, they're going to be in the DMZ zone, right? Okay, all right. So guys, as we said, that it's this project that we're going to modify. We have two SP, we have two routers here, but now we're going to replace with the firewall. Then we have actually the two multi-layer switches. So without any further ado, I'll just start the design part. All right. Okay. So when I come on the here, what I need first, I need two routers to act as our ASP. Good. So in this case, I'll just take a 2911 router and put them somewhere here. Those are our ISP. This will be our ISP1, ISP2. Okay. Then we need two firewalls. Okay. We need two firewalls. For the firewall, we're going to choose 5506. Just put two firewalls there. Once you have the two firewalls, now let's go to the multi-layer switches. For the multi-layer switches, we're going to choose 3650. Okay, we're going to choose 3650 multi-layer switches. Okay, all right. So, and then how many we had? Remember, we had 3 floors. We had 3 floors here. We had 3 floors, right? And the first floor, let's assume the first floor will contain marketing, sales and marketing plus human resource and logistics. Okay, so let's put a representative there in regards to switch. So let's just assume that that will be our sales and marketing switch. Then this one will be our human resource and logistics switch. Okay, then in the second floor, let's assume we add finance and accounts plus admin and public relationship. So we need also 2 switches there for finance and accounts, and then we need one for public relationship and admin. Yeah. Then finally on the third floor, actually, we add ICT department and the server room. So remember, ICT department is so big because it contains a lot of users. Okay. Yeah. So we're just going to represent it with one switch. Actually, we're just going to present it with one switch. So let's assume that will be our ICT department there. And finally, we'll have our server. Remember, we're going to have 2 locations where we put our servers on this design. One will be inside, the other one will be the DMZ. So let's assume that this is our inside server zone, where we're going to put the DHCP, DNS, and radius. Okay. But DMZ server zone will be attached to the firewall here. Okay. All right. So don't worry about that thing. The Active Directory server should always be in the inside zone. Okay. Yes. So guys, as you can see, we have the required networking devices. We have the ISPs, the 2 firewalls, the 2 multi-layer switches, and the 6 access layer switches. And the second thing that I'll do the connection. So to do the connection, we normally start from the top. Okay, and in this case, just choose automatic cable type and start from the top going down. Okay, so as you can see, we've made the connection between the networking devices. You can see we have redundancy all over the network. Yeah, and one thing that I would like to mention also, we need to connect the 2 layer switches to implement either channel. So just connect them. Yeah, so we have three. So we have 3 cable connection between the 2 multi-layer switches. Good. So we have enough of redundancy in this network. As you can see, it's going to be a very beautiful network design, just like the predecessor here. Okay. So this one serves as a degree or diploma project. But the one that we're designing, actually, this is a master's project. Okay. It's a very advanced project. All right. Okay, so the next step is just to include now the host devices plus other devices actually. So for the host devices, we normally require just a computer for testing. A department should have a printer for printing. Then we need a VoIP actually. You're going to choose the fast IP phone. We need a VoIP. We need a VoIP phone. Yeah. Just one VoIP phone can be enough, or we just use 2. Yes, we just need 2. Let's just, in this case, use 2, right? Okay. We need a printer, a PC for testing, VoIP phone, and access points plus wireless devices. For the wireless devices, we need a core laptop. Remember, users will be using laptops. We need a tablet. Many people have tablets. Then a smartphone, actually, very important. Then now let's put in the lap, which is lightweight access point. So for that one, you just come to networking devices, wireless devices, then choose this one, this lap PT. Okay. So that lap PT, we're going to manage it using wireless LAN controller, right? Good. So this is this network. Okay, so the next thing I do, I just want to turn them on. Just click them under the physical tab, drag IP phone power adapter and place it there. Same applies to this one. Then for the lightweight access point also, they have to turn them on. Just drag the power adapter and put it there. And finally, for the laptop, we are going to remove Ethernet adapter or slot and put wireless slot. So remember this one, this is just an Ethernet slot. So just turn the laptop off first, then remove this slot there and drag this WPC thread, put it there, then turn it on again. So we are done with the next step. Let's just connect them very fast. Good. So after we made the connection, now we can just do this one. Just copy that way, just mark that way, and just Control C and Control V. Then the way that they just marked, just drag them. Oops. So I have to undo and copy again. Control C, Control V. Then the way that just marked, then drag. Yes. So I'll do that and connect them very fast, save time. Okay guys, so as you can see, actually I've connected all the host devices in all this department, except the last switch, which we say that we're going to connect the servers. So on the last switch, I want to say that we're going to connect servers and the controllers. So the controllers are like voice gateway and the wireless LAN controller. So I'll need how many servers? 3 servers, one for DHCP, DNS, and the radius server. Yeah, so we have 3 servers there. Then I need controllers. The wireless LAN controller plus voice gateway for VoIP, right? All of them will be placed on the switch here. Good. So I just need wireless LAN controller. Just come to wireless devices, then choose this one, 2504. And now I'll just place them somewhere here, not below there, because to differentiate them from the rest of the hosts. Okay. All right. So I also need VoIP. So for VoIP, I'll need 2811 router. Just scroll to the last one, 2811 router. Strictly choose 2811 router. I repeat, strictly choose 2811 router. Good. So this one will be for wireless LAN controller. And remember, when you're going to implement VLAN, ensure that this wireless LAN controller is in the same VLAN with all the access point. When you're going to implement VoIP, ensure that this voice gateway is in the same VLAN with the IP phones. Okay. All right. So let's connect them very fast. Okay, so that's done actually. So we've connected all the required devices. All right. So the only part that is remaining is connecting the DMZ zone. So for the DMZ zone, we were told here that the DMZ, the zone can be attached to any firewall as of now. Being that we have two firewalls, and I don't want to make this configuration complicated, let's just attach the DMZ zone to only one firewall. So in this case, I'll choose this firewall. Okay, so for that one, I'll just take a Cisco access switch. All right, I'll just take that switch and put servers. So I'll need at least 4 servers. So actually on this design, it's only on the DMZ that we have a single point of failure. So you can see on the DMZ we've not implemented redundancy. Okay, so when this cable cuts or even this switch is down or the firewall, then the DMZ resources cannot be accessed. That's why I'm saying in the next video, we're going to, I don't want to connect this switch to this firewall again, okay? Because of the complexity of this design. If I'm forced to connect it, then I'll be forced to include a layer 3 device in between them, okay? But I don't want to make it more complex. So in the next video, in the next project actually, I promise whenever we have 2 firewalls, then you're going to implement a redundancy for the DMZ zone, okay? All right, but as per now, let's just connect it to one firewall, right? Okay, good. So the next thing we said that actually the main objective of this design is to enable this is a cloud company, a cloud solution company. Then it should connect the clients outside or globally. Thus, we should have an aspect of cloud, right? Okay. So to include a cloud here, actually, I'm just going to use a kind of a router. Then bundle it into cloud, right? Okay. So I'll just click on the routers. So I'll just take 2911 router to be our cloud router, okay? Then remember, we want to connect some users to the cloud. So to connect them, let's just assume that there's a virtual switch somewhere, right? Okay. All right. Then we need 2 users. One maybe in this is a Kenyan company. So let's assume the one is in the USA. Another one is in China, actually. Yeah. So I connect them. Yep. So this is our cloud. Remember, this is our cloud. So let's just assume these users are connected. We don't know how they are connected, but we just want to represent that they are connected. So this should be our cloud. So I just highlight them, mark them that way, then include this cloud thing. Okay. So that's our cloud or internet. Actually, you can name it internet or cloud. Yeah. So whenever we are going to implement, when we are going to actually when we are going to configure the inside devices, we're just going to click that inside that cluster, and we configure all and go back. Or you can just grab this thing, this delete thing. Okay, just grab that delete thing and come and click there once and uncluster. Then we configure. After we finish configuring everything, we mark them and bundle it again, right? Okay. So the next thing, actually, you can see this is a very nice project, very nice project. So the next thing that we're going to do here, actually, guys, is to name the devices, which is very, very important. In our network design and implementation, we normally ensure that all the devices in the network are named appropriately, okay? All right, so I'll just do that very, very fast to save time. Okay guys, so I've managed to name all the devices in the network, and the second thing that I'll do, I mean the next thing that I'll do now is to separate the borders and give a background color to each department or each segment. Okay, all right, so for that I'll also do it very fast, save time. So I believe these are things that you've been doing actually, so just a repetition of what we've been doing. Okay guys, so as you can see, we've done background decoration, and now our design is looking very beautiful, as you can see. Yeah, so I've separated the borders for the department, the floors, etc. So what's remaining here is just a little bit of comments, of which I'll do very fast also to save time. Okay, so as you can see, I've done the namings. The namings plus the comments that are necessary. So if I can just explain a little bit of the comments, you can see these are sales department, and it will have several VLANs: VLAN 10 management, 20 for LAN, 50 for VLAN, 70 for VoIP, and finally 199 for black hole. And all the IP address is going to be via DHCP. Okay. All right. So another thing that I need to mention here, let me just see. So before we go to implementation part, let me just see which I can add. Okay, so we're done with the first part of network topology design, where we've designed this beautiful topology, the secure company network system design and implementation. So in this second part, actually, we're going to start on the implementation part. So this config guide is what is going to guide us on what to be added on each device or component in this topology, right? Okay, so we're in the second step, which is the basic settings to all devices plus SSH plus standard access control list for SSH. So here we're going to do our basic settings to all the devices and add SSH plus standard ACL for SSH. So for the only devices that we're going to do the basic settings, the only devices that we're going to cover in step 2, which is number 1 here, are from the multi-layer switches going down, okay, and also the DMZ switch. I'm not going to configure basic settings on the firewall. On the firewall, the firewall is the last thing that we're going to do. So as per now, we're not going to touch firewall because I would like us to get better understanding of the firewall step by step. Okay, so the firewall is the last thing that you're going to do. Okay, so for the basic settings, I'm just going to do this DMZ switch, then from the core switches going down. Okay, and we're going to add SSH plus standard ACL for SSH. The standard ACL will only allow the management network to remotely access the devices. Okay, we're going to create an access control list, a rule that only allow management network to manage the networking devices. All other networks will be denied. Okay, all right, good. So as our culture, we normally configure one device, okay, step by step. All right, then we write commands on Notepad and copy paste to all other remaining devices. Okay, very fast, save time. So for demonstrating purposes, I'll just start with this sales and marketing switch. Okay, all right, so I just click on the sales and marketing switch, right? Okay, then you come to CLI, enable and config T. Good. So among the basic settings that we're going to configure here, you can see on the case study, we were told to configure, just a minute. Here is the case, the basic settings. Yeah, here. Then we're going to configure hostname, console passwords, enable password, banner messages, password encryption, and we're going to disable IP domain lookup. Okay. All right. And most importantly, we should not forget username and password. Okay. Okay. All right. So let's just go back to Packet Tracer. So we start hostname. Hostname to be, these are sales and marketing switch. So just name it SM switch. Good. Then line console password. We just say line console 0. Okay. Then you just say password to be, you write something, anything. But in my case, I always like using Cisco just for demonstration purposes. Okay. But in your case, you use a very strong password. Okay. All right. So line console 0, password Cisco, then log in. Whenever someone enters this parameter on line console as the password, then they should be authenticated and they should be logged in. Okay. Good. All right. So another important thing that I want to include here is actually login synchronous and exec timeout. Okay. So after some time of inactivity, the user should be logged out automatically. Okay. So exec timeout to be 3 minutes 0 seconds. Okay. Then login synchronous to prevent unnecessary logs from disrupting our configuration. Login synchronous, and you just hit enter and exit the line console. Good. All right. So we go to enable password. Just set enable password to be Cisco. I just use everything as Cisco. Okay. Good. So another thing that we're going to configure is banner messages, password encryption, and disable IP domain lookup. Okay. So banner MOTD, banner message of the day MOTD. Okay. Then you write any character. I'll write that hand character. Okay. Then you come back inside that character and you just say any message. Maybe you have to give a warning. No unauthorized access. No unauthorized access. Okay. Good. And you just hit enter. Right. So another thing that we want to do is disable IP domain lookup. Just say no IP domain lookup and you hit enter. Good. So the last thing here is password encryption. Well, all of these passwords, the way we've configured them, if you can just show the running configuration or the startup configuration, you will see them in plain text. So it's someone can easily extract our password and maybe compromise our devices when we are not aware. So to turn this password into readable format, just say service password encryption. Yeah. So that command will encrypt everything. All right. Good. All right. So we've configured several basic settings on this switch. So we need to do SSH plus ACL for SSH, okay? All right. So to configure SSH, there are some basic settings that we have to configure, all right? So the first thing is called username and password. We have to configure username and password that a remote user will use to access the devices. So just say username, I just use Cisco, password to be Cisco, all right? And we hit enter. And also the most important thing is IP domain name, right? The switch or the device should have domain name. Just say IP domain name to be cisco.com. Just want to use Cisco for everything, okay? IP domain name can be cisco.com, okay? All right, good. All right, so after you've configured the username and password plus IP domain name, now you can generate crypto key. So just say crypto key generate RSA, general keys modulus length to be 1024, okay? And you just hit enter. Good. All right, so we've generated the crypto keys, and you can see it will the name of the key, the name of the key will be ssm.cisco.com, okay? All right, so let's enable SSH. Just say IP SSH version 2. Good. So we've configured the SSH, but we've not appended the SSH configuration on the VTY interface. So remember, VTY interface, it's that interface that the remote user uses to remotely access the device. So you have to append the SSH setting on that interface. So just say line VTY 0 to 15. Just want to use 0 to 15, okay? And just say login local. That means it will use the username and password that I've just created, okay? Local database. Good. Then transport input SSH. We only want remote access to happen via SSH. Remember, there are two methods here, telnet or SSH. Telnet is not secure, SSH is secure. So we want only to happen via SSH, okay? And just hit enter, exit, and do right. Okay, so let's do the ACL access control list for SSH to allow only the management network to access the devices remotely. Okay, all right. So just say access list. We can name it anything, even one. Then permit the management network. So the management network here was this one. 192.168.10 yeah. So the management network is 192.168.10.0. Then the wildcard mask 0.0.0.255. Okay, all right. So let's deny any other IP from accessing access list. Access list 1, deny query any. Now, yeah. All right. So we've created an access rule, actually access control rule, to only allow the management network, and that access rule will also deny any other network. So let's append this access rule on the VTY interface, because it's a VTY interface that we want people to access to use for remote access. Okay, all right. So we have to append it on the VTY interface. All right. Okay, so we have to append this rule on the VTY interface. So we just say line VTY 0 to 15 access class 1. It's access class 1, right? the number is 1, then in. Let's query. Yeah, that's all. Access class 1 in. Yep, there's just exit and do right. So we've done with the basic configuration on the switch. So let's write commands on the notepad and copy paste to all other remaining switches. Okay, you're not going to touch firewall. We don't have root. Oh, we have routers actually. We have this router, but we don't need to configure basic settings here. Okay, all right. So I'll just do the mod layer switches and this access layer switches. Okay, all right. So when I open Notepad, actually, new tab. So let's start writing commands. The first command is hostname. It's always enable, then config t, all right, then host name. In this case, it will be this switch, HR and logistic, all right, HR and logistic switch. Good. And then we go to line console. Line console 0. The way we did here. Just follow this one. You go to line console 0, then we set a password. Just say password to be Cisco. Okay. And I really ask you, I ask you guys to be very careful when configuring the when writing on the notepad, because when you miss something, it's case sensitive. You are doomed. Okay. So just ensure that you write a correct word. Okay. Good. So password is Cisco. Then log in the user, authenticate the user. Then log in synchronous to prevent unnecessary logs from interrupting our configuration. Okay, login synchronous. Yeah, yeah. Ensure you're writing correct English. Exec timeout, such that exec timeout. Yeah, such that when we are idle for maybe 3 minutes, we are being logged out and we are required to log in again, then exit actually. So we are done with the that's line console. Now let's go to enable password and banner MOTD. So just say enable password to be Cisco. Everything to Cisco. Good. Then this one now. Banner MOTD. I'll just copy this. Sorry. Banner MOTD. I'll just copy this message here. Yep. So banner MOTD. Yeah, maybe to give a warning. Yep. And now IP domain lookup. No IP domain lookup. Good. Yeah. Then we go to service password encryption to encrypt the password. Service password encryption. Password, it's one word. Ensure it's a correct English. Yep. All right. So it's like we're done with the some of the basic settings that we're doing. Now let's go to SSH configuration. For SSH configuration, we have to configure username and password. So username to be Cisco, password to be Cisco. Okay. All right. Then of course you have to give it a domain name, IP domain name to be cisco.com. All right. Good. Then after we've done the settings, now let's generate the crypto keys. Just say crypto. I just copy this command. Crypto key generate RSA general keys modulus the length to be 1024. Yeah, good. And I paste there. Then now enable SSH IP SSH version 2. Good. Then now let's put the SSH configuration on the VTY interface. Yep. So okay, so just say line VTY 0 to 15. Login local to use the local database. Okay. Then transport input SSH. We only want SSH to be used as a method of remote access. Good. And then we just done there. Exit. So SSH has been appended on the VTY interface. So whenever you want to remotely access the device, you have to strictly use SSH, and you have to use the local database, which are username and password. Good. So another thing that you have to configure here finally it's access control list for SSH, because we want only the management network to remotely manage these devices. Okay, so just create that rule of which I've created on this side. Access control list 1 permit the only management network. Okay, then the same access control list should deny any other IP. Deny any other IP. Good, that's all. Yeah. Then now let's append this rule on this interface. Okay, right. So I just copy no, I just copy this one only. Good. Then paste it there, and I say access class now. Access class 1 to get inside, then exit, and finally do right. Wow, so we're done with the writing the commands on the notepad. So what's remaining is just to copy paste on all other remaining switches. So when we go to each switch, what we're going to modify is only host name, because these switches have different host names, right? Okay, so that's only what we're going to modify as per now. We're just going to modify host name of the switch. Everything will remain the same. Okay, all right. So let me just confirm if there's any grammatical error here. I can't see. So let's test let's just test this on HR and logistics switch first. If everything is okay, then I'll just proceed very fast. No, just paste. Let me just see if there's any error. Good, we don't have any error. So guys, let's meet when I've done pasting these commands on all other remaining switches. Okay guys, so I've done the basic settings on all the access switches, but you're not done for the multi layer switches, because there's something that I want to show you that might disturb a few guys. So I don't want someone to be left behind actually. So just click on when I try to click on the multi-layer switch and I come to CLI to paste the commands, I'm seeing this thing. The device must be powered on. It's very easy. Just click OK, and under physical tab, just drag AC power supply and put it on the empty slot. That's all. Just give it like 20 seconds, it will be up. Also on this side, drag AC power supply, put it there, and close. So let's just give it some like 20 seconds. Yeah, now this one is up. Just click here, come to CLI, then I paste. Good. So guys, basically we've done the basic settings in all the required devices. We're not going to do in the firewall, okay? Now, because you say that the firewall is the last thing that we're going to tackle, okay? But we don't control ISPs, we don't control the internet, okay? So these ones are out of our control, okay? So we don't touch them. We're only going to touch them maybe to configure OSPF, just to test, okay? All right, so that's okay. All right, So I don't want to configure this voice gateway now. Okay, I'll touch it when I'm going to configure VoIP. Good. So we're done with the second step, which is number one. We're done with the number one. So let's do number two. Good. So VLAN assignment plus all access and trunk ports on layer 2 and layer 3 switches. Good. So guys, this is very important part here because these are VLAN network with the VLANs. So when you miss anything regarding VLANs, you won't achieve the desirable results. So you have to be very, very careful with the VLAN assignment, okay? All right. So let's just do it slowly but slowly. Yeah. So I'll start with the access layer switches. Whenever I'm connecting the devices, I always ensure, whenever I'm connecting the devices, I always ensure that the first two ports, FA1 and FA2, connect to the multi-layer switches such that they become trunks. Okay? All right. So, whenever we're going to configure trunk, the first two ports should be trunks, right? Okay. So, and we have several VLANs here. We have management VLAN, LAN VLAN, WLAN VLAN, VoIP VLAN, and black hole VLAN. So management, it's used for management. LAN will be used for those who connect to cable via LAN ports. Those who use cables, okay? WLAN, Wi-Fi users. VoIP, IP phones. Black hole, this is where we are going to put unused port. Oh, any unused port will be put into black hole, and they should be turned off such that someone cannot connect to them. Okay, all right. So let's just click on the switch, just step by step. Then I write commands on Notepad and copy paste to all other switches. Okay, all right. So you see we have a password here, but in most cases I don't want to write the password. I just want to bypass that. Just come to config and click any interface. Yeah, you've just bypassed that. All right. So we've said that FA1 and FA2 to be FA1 and FA2, FA1, this one, and FA2, FA1 and FA2 to be trunk. So just say interface, interface range, FA1 to 2, FA0/1 to 2. Switch port, mod, trunk, exit. Good. Now let's create VLANs. After we specify that these are trunks, now let's create VLANs. VLAN, VLAN 10, name, MGT, management. VLAN, VLAN 20, name, LAN. VLAN, VLAN 50, name, WLAN. VLAN 70, name, VoIP. And finally VLAN 199, name as black hole. Black hole, yeah, good. All right, so we've created the VLANs. So now it's a time that now we assign ports the role of access and give them VLAN assignment actually, right? Okay, so any port that connects to access point will come under this one, VLAN. Any port that connects to IP phone will come to this. All right. So as per now, we're not going to send any port on these switches, the management network, right? Yeah. we're only going to assign a port in ICT department, a management network, but not any other department, okay? Because it's a ICT department where we have network administrators, and they should be in management network to administrate these devices, okay? All right. So now let's proceed. Let's start with the um, VoIP. Yeah. So let's start with the VoIP. So when I move over this switch here, let's see the VoIPs are connected to FA05, FA06. The computer is connected to FA03 and the printer FA04 and the access points FA07. So let's start. As we said, the computers and printers, they will be under LAN VLAN. Okay, so let's do it. So interface FA0/3 to 4 interface range, yeah. So you can see the computer is connected to FA0/3, the printer is connected to FA04. So we just say switch port mode access, then switch port access VLAN, the LAN VLAN 20. Okay, good. Exit. Then we go to the IP phones. So the IP phones, you can see it's connected to a FA0/5 and a FA0/6. So interface range just come 5 to 6. Switchport mode access, then switchport access VLAN. It's VoIP. VoIP actually, you can see VoIP is VLAN 70. Yeah. Then finally the um the access points. You can see the access point is connected to FA0/7. So interface FA0/7, interface FA0/7, switch port mode access, then switch port access VLAN 50 for WLAN Wi-Fi. Yep, yep. So exit and the black hole. We say that any other unused port should be placed into black hole. So we've only used in this demo, we've only used, as you can see, we've only used from port 1 to port 7, up. From port 8 to 24 and gigabit Ethernet 01 and 02 are all down. So we want to place them into the black hole VLAN and shut down all of them, okay? Good. So just say interface range FA0/8 to 24, comma, we only have gig, we also have gig, you can see it's a gigabit Ethernet 01 and 02. So 0/1 to 2 and just hit enter. Switchport mode access still, then switchport access VLAN, the black hole 199, then shut. We have to administratively shut down all of them. Good. Exit. Do right. So we are done there. So the same thing we do on all other remaining switches. Okay. So being that I've demonstrated here, let me just write commands on Notepad. Okay, and do it very fast, save time. So I just want to confirm whether also these interfaces, this one should be FA0/3, FA0/4, 5 and 6 actually, yeah. Then this one becomes 7. I was very consistent. That's why I normally like consistency in my cabling. Okay, good, yeah. So it's very consistent. I like it, yeah, sure. So ensure that you are putting the right VLAN to an interface. because you might face problem. During cabling, I was very consistent with my configuration. Yeah, so I'll just try to squeeze it there, and we open Notepad. I delete the previous configuration. So as we said, port 1 and port 2 from FA1 to FA2 should be trunk, okay, in all the switches, because I was very consistent. Switch port mode trunk. Yep. So then we exit the trunk interface. Good. Then we go back. We go to and create the VLANs. We are going to create all these VLANs. So we start VLAN 10. We name it as MGT. VLAN 20. We name it as a LAN. VLAN 50. We name it as a VLAN. VLAN 70. We name it as a VoIP. And finally, VLAN 199. We name it as Blackwell. Yep. Good. We exit the VLAN interfaces. Yep. So we've created how many VLANs? We've created. We have actually. We have actually 5 VLANs. Yeah. So let's assign VLANs to interfaces. For example, if a range, this one should be in VLAN. You have to be very ensure that you are checking the correct interface, because in my case, I assume that, not I assume, I'm very confident that /3 and /4 are connected to PC and printer. Okay, yeah. So where is it? Yeah. So switchport mode access. So switchport mode access. Yes. Then switchport mode access VLAN 20. Yeah. Then exit there. Then we are going to, it's this department. So we say FA0/3 here. Sorry. FA0/3 here, and 4 to access VLAN 20, the LAN VLAN. Now 6 and 5 to VoIP VLAN 70. 6 and 5, I just copy this one. Copy and paste 6 and 5 to be VLAN 70. 6, no, 5 to 6. 5 to 6 VLAN 70. Yep, for VoIP. Then this one is interface 7. Sorry. This one is /07. /07 to access VLAN. /07 only one. Now I delete the range because it's only one interface. To access VLAN 50, the VLAN, this access point. Okay, all right. And finally, the black hole. Remember, when you came to this switch, here, we saw from this range here. This range is unused. We don't use any of those interfaces. When you want to use it, we will reassign it to the correct VLAN and turn it up. Okay. So I paste there and just copy this. Actually, I just copy those and make this one to be 199. Okay. All right. So this is what I'm going to copy paste to all other remaining switches. Okay. Yep. So I'm very sure that this is the correct one, because normally I'm very consistent when I'm configuring when I'm connecting the devices. Okay. All right. So I do it very fast step time. Oh, I forgot to mention something. Remember, we were supposed to shut these interfaces down. So, yep, shut. Do right. Yep, we were supposed to shut all of them down, but I forgot. So let me just write that command here before I proceed further. Yep. So let me do it very fast. Okay, so guys, we read somewhere here, and I want to say something. I'm sorry I didn't mention it at the start, but for the inside server switch and the DMZ switch, the DMZ switch you're not going to configure any VLAN at all. I repeat, the DMZ switch we're not going to configure any VLAN at all. So the configuration that we're doing now won't apply here. So when we come to the server switch here, when you come to the server switch here, we're going to configure how many VLANs. We're going to configure here now. I'm not going to configure the black hole VLAN, and just a minute. We have to make a suggestion here. Actually, we should make a suggestion here. These servers should be in a different network from the LAN, VLAN, VoIP, and the black hole. Yeah, so here I'll edit this one. Inside servers to have maybe VLAN, let's say VLAN 9, VLAN 90, yes. So you see these servers, they will be in VLAN 90. Yeah, that's what I want to do. These inside servers, they should be in a different VLAN from the LAN, the VLAN, the VoIP, yeah, or the management. Yep. So here we're going to configure how many VLANs? Actually now 5 still. We've already removed the black hole, but we're going to ensure that this interface FA06 actually is in VLAN 50. Yep, for VLAN, because this wireless LAN controller, it should be in the same VLAN with these access points. Keenly, step by step, yep, and very slowly. We don't want to move fast, okay? Just, we don't want to leave anyone behind. Yep, this one should be in VLAN 50 with these access points. Then, this interface will be trunk, okay? It's very simple. It will be trunk, okay? Because we want to configure inter-VLAN routing here, okay? Such that this first gateway will be providing IP addresses and dial numbers to the IP phones that you see here, okay? So this interface will be trunk. So FA0/7, FA0/1, FA0/2, 1, 2, and FA0/7 will be trunk. But this one, and this one will be access port accessing the inside server's VLAN 90. So here I'll do it. I'll just do it again here. So when you come here, interface range FA0/1, FA0/1 and 2, this one and this one, okay? Then now we add 7, which connects to the voice gateway. FA0/7. Just write comma and space FA0/7. All of them will be trunk. Okay, good. Now we create VLANs. VLAN 10, 20, 30, 40, 10, 20, 50, 70, and we name this one as inside servers. Okay, we give it VLAN. Oh, sorry. VLAN 90, we name it as inside servers. Yep. So when you come here, we say this is FA0/3, FA0/5, and FA0/4. So from 3 to 5, interface range from 3 to 5, interface range from 3 to 5. Okay. Switchport mode access, access VLAN 90, the servers, inside servers VLAN, because they are connected to the servers. Okay. All right. So we say that this interface FA0/6 should be VLAN 50 or VLAN. Good. So interface FA0/6, just delete the range. It should be VLAN 50. That's all. That's all assignment that we want here. So I'll just delete all other remaining assignment. Yep. So we don't need to assign the LAN VLAN to any interface. Okay. All right. Good. So let me just check again. 3 to 5 are servers, connect to servers. VLAN 90, the inside servers. Okay. FA0/6 connect to wireless access, wireless LAN controller. Okay. VLAN 50, correct. The Cisco voice gateway connects to this interface, FA0/7. It should be trunk. Okay. All right. So I hope that one is clear. If it's not clear, then actually I apologize, but I pray that it's clear for you. Oops. So there's a problem here. When you're naming VLANs, it should be in one word. We have one problem here. When you're naming VLANs, it should be in one word. So I'll name it again. So VLAN 90, name inside servers. Yeah. Do show VLAN. It should be in one word. So inside servers, you can see 3 to 5. Our VLAN is that one. Yeah. So that's all about it. That's all about basic set the VLAN configuration on the access switches. So now we jump over to the multi-layer switches. So for the multi-layer switches, we need to configure trunk, and we just have to configure VLANs, but not assign them to any interface. So when I come here, I just want to do it very, very fast. Just ensure that this gig 103, gig 104, gig 105, and gig 106, gig 107, gig 108. So from gig 103 to gig 108 should be trunk. Okay, the same will apply here. Yes, from gig 103 to gig 103 to gig so interface range gig 1/0/3 to 8, gig 103, gig 103, gig 103 to gig 108 should be trunk. Okay, should be trunk, both switches. Okay, All right. So we create VLANs. We have how many VLANs? 10, 20, 30, 10, 20, 50, 70, 90. So for black hole VLAN, I'm not going to include it on the multi-layer switches. We don't need it there actually. I don't need it there. I only need to access ports where users connect. These multi-layer switches are actually they only connect to the core. I mean the firewall and the access switches. It's only access switches that connect to the users. So users can access our network via access switches. Okay, so that's why we only configure the black hole VLAN here. I'm not going to do black hole VLAN here because no user can hide into our data center and connect to this port. Okay, all right. I'll just assume that way. Yeah. So I'm just going to configure these VLANs. Good. And I'm removing this one. That's all about them. So I copy these to the two switches. The trunk faces the trunk ports are very important, which connects to the access switches, and also we create exact VLANs that we created down here. Okay, we only leave the black hole. Okay, good. So just paste. Good. So we're done with the VLAN assignment. All the switches actually. Yep. So we said that we're not going to do any VLAN here. Okay. Yep. So there's something that we forgot actually during VLAN configuration. Well, when you're configuring VLANs for VoIP, we don't just assign them directly, like switch port mode access that VLAN. You have to specify that this is a voice VLAN. So for VLAN 70, as you can see, we're going to modify that. Okay, we're just going to modify that actually. Yep. So how do we do it? I just go to this switch and correct it. Sorry for that. We were supposed to specify that is a voice VLAN actually. Yep. So exit. So which interface were connected to the VoIP? It was consistent actually, FA05 and FA06. So I just go to FA05 and 06 interface range FA05 to 6. Okay, then you just say switch port voice VLAN 70. Yep, then you just do right. So if I can, if now being that this interface, this range has already been assigned a VLAN. The first VLAN that we assigned using switch port mode access VLAN 70 was for data. But we want our VLAN 7 to be that of voice. So we are going to remove that VLAN that we assigned it there. So sorry for that confusion, but it's good that you identified it early enough. So just say no switch port access VLAN 70. Okay. Yeah, so we can just return it to VLAN. Let me just try to go over it. We see which VLAN. Yeah, now it has been returned to the default VLAN, which is VLAN 1. You can see port 5 and port 6. The VLAN is 1. So the data VLAN will be just VLAN, the default VLAN, but the voice VLAN will be VLAN 70. Okay. All right. So I'll do that to all other remaining switches. All right. So it's always good to know the troubleshooting skills. All right, so I'll just do that to all other remaining switches so that we specify that port 5 and port 6 accesses voice VLAN. All right, then we disable the first VLAN that we set. when we do it this way, VLAN switchport switchport access VLAN 70, we mean that that's a data VLAN, but we want it to access we want VLAN 7 to we want VLAN 70 to be our voice VLAN, not data VLAN. Okay, so I just go here and paste that interface range, that one, then no switch port VLAN 70. Okay, all right, so no switch port VLAN 70, then we give it the correct VLAN number, right? Good. So after doing this, everything will just be okay. Yep, exit that range, then do right. Yep, so I just do this to all other remaining switches. Okay, all right, so let's do it very fast, save time. All right, so we're done. We were only configuring VLANs, the voice VLAN on. We were only assigning ports VLAN ID on the first 5 switches, but we didn't do for the server room switch. Okay, all right, so that's a correction that you have to do. You have to specify that that port will access voice VLAN. Okay, not just switch port switch port access VLAN. Right, all right, so that's all about VLAN. So that's all about the VLAN assignment. Let's go to the next step. So the next step, actually, the next step here is to 2.1, which is to configure HTTP port fasts and BP guard on all access ports. Good. Well, the BP guard and HTTP port fast, what they actually do is to make the port transitioning. Whenever you try to plug in, let me just demonstrate. Whenever I try to, which port is this one? It's FA0/4. When I remove it and try to plug it again, FA0/4, you see it will become orange for quite some time, maybe 20 seconds to 30 seconds. That's a that's a significant amount of time that will affect our productivity. So we want to turn green whenever we plug it in there. We want it to turn green immediately whenever we plug it in there. And we only configure port fast on access switches. Okay, so we're going to do here on the DMZ and all other remaining access switches. So in this case, I'll start with let me start with the servers, because there's something here I want to mention. Yes, there's something here I want to mention. Let's start with the servers department, inside servers. Yep. So we only configure the port pass and BPD guard on access ports, not trunks. So on the servers department, we had 3 trunks. This one was a trunk, FS7 and the 2. Okay. So when I come here, I just so when I come there, there's an interface range. FA/1 and FA/1 and 2 are trunk. So start from FA0/3 to 6, comma, then we skip number 7 because number 7 is also trunk. Okay, FA0/8 to 24. Yep. If it were if this was not trunk, then we could have just said FA/3 to 24. But being that this one is trunk and it's a 7, we just say FA/3 to 6. Then we skip number 7, comma, space, FA0/8 24. Yeah, so we just say spanning tree portfast, and you just hit enter. Yeah. So spanning tree, BPDU guard, enable, exit, and do right. So it's very simple for these switches. It's very simple. So I'll just do this one. I'll just do this way. Come back to Notepad and just say delete this one. So in these switches, we're just going to say FA0/3 to 24. Okay. FA, because this one is trunk, this one is trunk. FA1 and FA2 are trunk. Good. So interface range FA0/3 to 24. Then you just say spanning -3 port fast. Spanning-3 port fast, then spanning 3 BPDU card enable, and do right. So let's test. If there's any error, I'll just rectify. Yeah, so there's no error actually. There is no error. Yep. So everything's okay, just okay there. So if I can just try to remove again from FA4, then I return to FA4, it will turn green immediately. See? Yep. No productivity affected. So let's just do it very first time. Good. So we've done for the switches. Remember we started with the server switches. Now we are ending with the SSD switch. Don't forget and paste the same configuration on the servers. I mean the inside server switch. Okay. All right. So finally, let's do the spanning tree parameters here. So here actually, all of them will be access. So just say from 1 to 24, spanning tree. Yeah. So here there's no problem at all. From 1 to 24 will be access ports. Yep, good. So we're done with the spanning tree. STP, we're done with the spanning tree, BPDU guard, and portfast. So the second step here, the third step is EtherChannel. Well, EtherChannel, same way how people call it, EtherChannel, or how I call it, EtherChannel, is a link aggregation protocol. We are going to bundle multiple physical links into one logical channel or channel. So this one logical channel will be aggregated and used to transmit data. We are only going to configure either channel here. Okay, so I'm just going to take this background. Yeah, so we're going to configure which either channel protocol. We're going to configure LACP. I believe so. There was a LACP. We're going to do LACP either channel. So I'll just write there LACP. Good. So we are going to aggregate the three links into one logical channel. Okay. So the first link was 109, 1010, and 1011. So it's very simple. Just go here and say exit. So interface range gig 1/0/9 to 11. Yeah. Channel group. How do we configure either channel? Channel group 1 mod to be LCP of which mods? active passive. So when you configure one side to be active, the other side should be active or passive. It should never be passive passive. It can be active passive or active active. So in this case, I'll just do active 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 or active passive. Okay, good. Yep. Then you see an interface has been created here. So I just copy this interface. Okay, interface port channel 1. An interface has been created there using our group number 1. Okay, so I press it there. Interface port channel number 1. Then switch port mode to be trunk. Exit and do right. We've configured EtherChannel successfully on that switch. So let's go on this other side and configure EtherChannel. So the same way we did there, it was, let me just confirm the interfaces, but I'm always very consistent when connecting the devices. Okay, 109, 1010, and 111. So, so interface range, gig 1/0/9 to 11. Okay, channel group, channel group number 1. You have to ensure that the group number matches both sides. Okay, mode to be, I did there active, I can do here active or passive. Okay, all right. So just let me just do it passive to make it look complete. Active passive, good. Yep. So an interface has been created here. Just copy this interface port channel group number 1 and switch port mode turn, exit and do right. So we're done with the either channel. Yep. So let's just give it some time so that it synchronizes, and I show you that the either channel has been formed. Yep. So meanwhile, let's go to this next step, which is subnetting and IP addressing. Wow, very important. Well, subnetting and IP addressing, you can never ignore them in any network. Okay, but they normally take a lot of time to calculate the subnets and write the IP addressing table. And to ease that, I've already done that. And this is our, so I've just put them on this table, as you can see. And all of these IP addressing were given here. This one. Yeah. So I've just used this to form this table here. Okay. All right. So you can see the management network is that one. The VLAN network, which is for Wi-Fi, that one. The LAN for the computers that are connected via the cable, that one. IP phones, that one. The DMZ, will that one. The inside servers, very important. The inside servers should be in the different network with these devices. Yeah, I've just located them that network. Right. Then this will be the IP addressing between the core devices, the multi switches, the firewall, the ISP, the cloud. Okay, all right. So what I'm going to do is just to comment on the diagram. I'm just going to comment on the diagram which network will be uh, which network actually is used there. Yeah. So I'm just going to do a very general comment on this topology. Good. So for IP addressing, I just copy this. I copy that and I come here and paste here. I paste there. So for management network, Okay, guys, so I've done IP addressing. Actually, I've just given the comments on the topology. As you can see, I've given a comment between the devices on what IP addresses that will be used between them, and for the general purposes for like management, LAN, WLAN, VoIP, DMZ inside servers, they have their IP addresses here. Okay, so I'll just try to copy this and paste niche department actually. Okay, good. So that's done. So we've just given a command on what type of IPs that will be used in each segment. So what's remaining is just to allocate IP addresses. Good. Good. So as we said that we're not going to touch firewall until the last time, the last moment. So I'm only going to allocate IP addresses on the multi-layer switches, the routers, and there's a router inside the cloud here. Okay. So let me just allocate IP addresses. So the firewall will always take the second IP address. For example, this interface of the multi-layer switch will take 10.2.2.1. This interface will take 10.10.10.2.2.2. Okay. This interface will take 10.2.2.5. This one will take 10.2.2.6, etc., etc. This firewall will take the second available or usable IP address. Good. All right. So let me just demonstrate with this multi-layer switch. For the multi-layer switch, remember, we want it to act both as a switch and a router at the same time. So let's enable routing on that multi-layer switch. So let's just do it very, very fast. IP routing. That's all. We've enabled routing on the multi-layer switch. So that's all about routing. So now let's try to configure IP address. So this interface, which is gig 11 and gig 102. The first thing we do, we enter those interfaces individually. Int gig 1/0/1. We just say no switch port. Let's turn it to a layer 3 interface. We don't want it to be a switch port. We want it to be a routable interface. Just say no switch port. Good. Then you assign it IP address. No shut first again. Then you assign it IP address. So the IP address will be 10.2. IP add will be 10.2.2.1. 255.255.255.0. Good. So we've assigned IP address to gig 11. So let's go to gig 102. So gig 102, no switch port, then no shut. Then you give it IP address. Oh, now it will be 10.2.2.5. 10.2.2.5. There's a mistake that I've just made. This should be /30 notation 252. Yep. So let me change that first. The first one. Yeah. So let me just change it first. 252. Yeah. That was the mistake that I made. It should be /30. Okay. 252. Then I go to this interface and now assign the correct IP address. Now it won't overlap. exit, and do right. Let's do the same on this side. So this one is let's start with the gig. Let's start with the gig 101. Interface gig 1/0/1, gig 101, no switch port. Okay, no shut. Then IP add will be 10.2.2, 10.2.2.9, the first available IP address. Okay, 255.255.255.252. Then you go to gig 102, no switch port, no shut. IP address will be the first available IP address on this side, which is 13. Exit and do right. Good. So let's go to the routers and assign IP addresses. So on this router, go back. I'm going to uncluster it just for a moment. I'm going to uncluster it here. Yep. So after unclustering it, now we can just try to configure IP addresses very fast. So on the routers, being that I've shown you how to do IP addressing on the CLI. So on the routers, actually, just a minute, I just want to, yeah. So on the routers, actually, I want to do IP addressing using the GUI. So the first thing I'm going to do, I'm just going to try to minimize it and say top. Good. Then minimize it again. Sorry, you should just say top, then you minimize. Yep. So when you say top, now even if you click outside, the pop-up doesn't appear. Okay, doesn't disappear. Right. So we come to config. Then I come back here and I say this one is this interface is gig 00. I come to gig 00. First turn it up, then assign the IP address 105.100.50.1. Okay, 255.255.255.252. Yep. Yes. So that's okay. Then come outside here, check this interface. Then you come outside here and check this interface, which is gig 101. You come to gig 101, say turn it on, then send IP address 105.100.50.5, the first available IP address. Okay, that remains that way. Then finally you come and assign this one. Okay, gig 102. Come to gig 102 and do the same. So gig 102 is 20.20.20.1. Okay, 255.255.255.252. Yep. So it's very easy. I think I've shown you how to do it. So for the remaining two routers, I will do it very fast, same time. Okay, good. So I've configured IP addressing all the routers. Okay. All right. So the second thing that I'm going to do, so I want to configure static IP addressing to these two computers. Okay. All right. So I just click on this computer here and I come to desktop, configuration. So can be IP address can be 8.0.0.10. Yep. Then the gateway will be 8.0.0.1, which is IP address of this interface here. Yeah. Yep. So that's all. Yep. So that's all I want here. Then also on this side, I do the same, very fast, save time actually. Okay, so done with that one. Good. We will cluster these two components to look like cloud later, okay? After we've configured OSPF, okay? Right. Good. So what's remaining here is very simple. We've done IP addressing on the multi switches on the routers, plus the internet for our users, okay? Right. Good. So when I come back to our notepad, wow, very important concept here. HSRP plus interval routing on the layer 3 switches plus IP helper addresses. So we're going to do HSRP alongside the interval routing on the multi-layer switches and specify the IP helper addresses. Remember, we have our Active Directory here as our DHCP server. So all of these departments actually should come here for IP addresses, except for the IP phones. Okay, the IP phones will get their IP address from this router. That is VLAN 70. So here we're not going to create an inter-VLAN routing. We're not going to create an inter-VLAN for 70. Okay. All right. So we're just going to create an inter-VLAN routing for let's say management network. Yeah, maybe, but yeah, let's just say IP address for management network, LAN, and WLAN only. Okay, right. So what we're gonna do here, I'm just going to do a little bit of comment here. Let's assume that the DHCP server here, it's a 10.11.11. This is 32, 33, 34. Now, let's say 35. The DNS here is 10.11.11.36. The radius here will be 10.11.11.37. Yep. Good. So that's all. That's all about it. So let's do HSRP plus interval routing. Good. It's very important. Very important. So how do we configure HSRP plus interval routing? We configure HSRP inside the interval routing entries. Okay. So exit. So here we want to do HSRP. So I'll just use a yellow thing and say HSRP. HSRP. Good. So we're going to do HSRP between these two multi-layer switches. So we want to distribute our traffic such that each core switch acts as both the standby and the active router. We don't want to direct all traffic to one switch at a time. We want to distribute them at least to have that kind of load balance, okay? Right? So for example, two VLANs will have their traffic from one switch. Other two VLANs will have their traffic from the other switch, okay? But when one switch fails, all the traffic are being forwarded to the other switch. So let's just say active and standby. Active standby. I also come on this side and write the same. That is for HSRP. So just give it a color, maybe to differentiate and make it more visible. Yep. So each switch will be standby and standby plus active. Yeah. Because we want to distribute traffic between the switches. Yeah. So when I click on the switch, the way I've done before, we start by creating an inter-VLAN routing. Here, as we said, I'm only going to create an inter-VLAN routing for 4 VLANs. The first one, I'll just use this reference here because this is where our valid VLANs are. Let's forget about black hole VLAN. Now let's reference here. We're not going to do for VoIP because VoIP we have voice gateway. That's all. So we're going to do for inside servers, VLAN, LAN, and management. So for management and LAN will be on the first switch as the active. This first switch will be active switch for management and LAN. The second switch will be active switch or the active router. Let's just use a router in this case. With the active router for VLAN and inside servers. So good. So just say interface. Before we go deep in there, so I've just realized something here. I've realized something here that won't work the way we expect. So let's make it 38. 35 will be used by actually an inter-VLAN routing interface. I mean a VLAN interface, yeah. So can take this on there, take this on here, and take this on here. Sorry for that confusion. Yep. So yeah, because you can see this inside servers will have this IP address 10 11 11 32/27, meaning 33 will be used by the standby, 34 will be used by the first VLAN interface, the first VLAN interface, and 35 will be used by second inter-VLAN interface. So that's why I've removed it here. Okay, good. So let's proceed like we said. So interface VLAN 10, okay, then no shut. Then we assign it IP address. So VLAN 10 is a management network, and the management network you can see 192.168.10 or something. So just say IP add 192.168.10. Being that you want this first switch to be the active router for VLAN 10, now we give it the highest IP address. So we are reserved 3 IP addresses here, 10.1.2.3. So the highest IP address will be .3, okay? 255.255.255.0. Good. And then standby. Standby for VLAN 10, we give it. Now here, now we configure inter-VLAN routing. We start by standby. Standby 10 to differentiate that group. Standby group 10 for VLAN 10, okay? IP to be 192.168.10.1, the first available IP address, okay? And we hit enter. So let's configure IP relay agent. So just say IP helper address to be IP address of the DHCP server here. Okay, 10.11.11.38. Good. So we are done with the VLAN 10. We exit. Believe we're done with VLAN 10. Let me see if there's any additional thing that I need to add there. I can't see there. Yeah, sure. So let's go to VLAN 20. There's some information there, but let's just ignore them for the time being. Okay. Interface VLAN 20. Then no shut. No shut. And IP add. Give them IP address. IP address will be VLAN 20, as you can see, it's a LAN. So the IP address will be 172.16.0 then .3. .2 will is assigned to the second switch. .1 for standby, okay? 172.16.0.3. The interface with the highest IP address becomes the active router for that VLAN, okay? 255.255.0.0. Hit enter. Then we go for standby. Actually, we go for standby. So standby group. You have to ensure that each VLAN has its own group. Don't mix up group, or else the HSRP won't work. Okay. All right. So this now I change it to 172.16.0.1. Okay. Good. Then IP helper address, very important. Just remain the same. Yeah. So let's go to VLAN. Let's go to VLAN. VLAN now. VLAN 50 for VLAN. So we said that this first switch will be active router for VLAN 10 and VLAN 20, but the second switch will be the active router for VLAN 50 and VLAN 90. Good. All right. So we go to VLAN 50. Go to VLAN 50, no shut. Then we assign IP address. IP add to be IP address VLAN 50 is VLAN 10.20.0.2 because we want it to be the standby router of VLAN 50. The second switch will be this active router for VLAN 50. So we'll give it 20.0.3. Okay. Very challenging, but there's something that you need to, there's sometimes that you need to force yourself to understand. .0.0. Okay. And then standby. I'll just try to retrieve standby 50. If you miss these standby groups, then your HSRP will want work. You have to ensure that if the VLAN is VLAN 50, each standby is standby 50, okay? To avoid confusion. So the standby IP address will be 10.20.0.1. Then IP helper address will always remain the same and exit. And finally, we go for VLAN 90. Okay, so interface VLAN 90. No shut. Okay, IP address will be VLAN 90. You can see it's inside servers 10.11.11.32. So 10.11.11.33 will be standby. Okay, 34 now. Okay, 255.255.225.224/27 notation, and I just hit enter. Good. Then standby 90 because it's VLAN 90. IP to be 10.11.11.33, the first available IP address. Okay. Then here, we don't write IP helper address because the servers we're going to assign them static IP address. Exit and do write. Then the most important thing that I want to do here, I just want to say do show start. Then after I've done that, I want to, yes, so this is where our concern is. The interval routing plus the HSRP. Yep, so ensure you mark them that way. Just ensure that you mark them the way I've done. Ensure you mark them the way I've done. So our concern is on the interval routing plus the HSRP. Yeah. So ensure that you mark all of them from the exclamation mark to the other exclamation mark and copy. And you open the notepad and when I just paste them there. Remember, these are the interval routing and HSRP config on the first switch, but we want to modify them so that we can be consistent on the other switch. The first thing, remove anything called MAC address. Remove anything called MAC address there. So the second thing, let's confirm if everything is just okay. Everything is okay. So let's modify this for the other switch. The only thing we modify is the IP address of the VLAN. So for example, okay, so we say that we're going to reserve three usable IP addresses. Okay, the first one. Okay, so the first one will be used for standby. The second and the third one can be used for the VLAN interfaces. Okay, so we now change this to 2. Okay, this one will change to 2. Okay, this one, because we wanted that switch to be a standby for VLAN 50. Now we change this one to 3. Okay. Yeah. So also this one we change to 5. Yep. So you can see the difference here. This one we're going to paste on the second switch. So you can see VLAN 90 here. It had IP address, which is going to have IP address of 35. Here it's 34. VLAN 50.2 here .3. Okay. VLAN 20 here .3 here .2. So it's just this way, very simple. And I copy and I go and paste on the other switch, which is this one. Okay. All right. So just and I just paste there. Do write. Exit. Do show start. Yeah. So let me just show you. You have to ensure that the IP addresses are if the other side is 2, this side is 3. If the other side is 3, this side is 2. Yeah. So you can see 90 here, .34 here, .35, 50.3 here, here is .2, 20 here, .3 here, 20 here, .2 here, 10 here, .3 here, 10 here, .2 here. Okay. All right. So I want us let's just give it some time so that they can synchronize. For example, let's just give it some like 20 to 30 seconds so that they synchronize and will show standby IP and standby show standby brief. So as per now, you can see everything is standby. Let's just give it some time. Also on this side, On this side, you can see everything is active. Okay, we will show the command again. Let's just give it some time. If it doesn't synchronize on time, you can just restart our packet tracer and show later. Okay. All right. So meanwhile, I'll just go to the next step as we wait for the HSRP to synchronize. Yep. So the next step is static IP address to DMZ server farm devices. Is static IP addresses to DMZ and server farm devices. Okay. All right. So let's do static IP address to these servers. Okay. All right. Let's start with this one. We said that our DHCP server will be 36. Did we really make it 36 here? Oops. Here we use 38. Okay, no problem. You can just interchange them. So our DHCP server will be .38. So let's just assign them IP addresses very fast. .38 here. It's /27 255.255.224. The default gateway is very simple. The default gateway is the standby IP here. Where is it? This one. This is the default gateway. Okay. All right. So very simple and interesting. So the default gateway will be .33. The next server actually is this one, .37. All right. So I'll do the other two servers very fast, save time. Good. So we've done the servers, the inside servers IP addressing. So let's do IP addressing to these servers. So these servers, you can see, they have they have a network of 10.11.11.0. Okay. So let's assume that 10.11.11.1 will be taken by this interface, which will be the default gateway for all of these servers. Okay. All right. So let's just start with the FTP server and allocate it IP address of maybe .10. Okay. And it's 255. Okay. Then default gateway will be the IP address of the firewall, which will be 10.11.11.1. Okay. Our DNS actually, these are the DMZ. We can make our DNS just to look .30 to 37, the one that is in our inside servers. Okay. All right. So I just do the same for other remaining servers. Very fast, save time. Good. So actually we're done with the static assignment of IP address to the servers. Okay. All right. So the next step actually is DHCP server configuration. Very important. You're going to do DHCP server configuration. So let's just go here and configure DHCP. Good. So ensure you make it top so that you don't be interrupted. Then I scroll this so that I see the networks here. Yeah. So this is our DHCP server. Come to services. Okay. After coming to services, so what we can just do, we come to DHCP. And before we do anything, ensure you turn everything to 0.0.0.0.0. Okay. 000. Ensure you turn everything to 000. Good. Alright, then turn it on. Now start editing pools. So actually we want 3 pools: management, LAN, management, LAN, and VLAN. VoIP is for the voice gateway. Okay. Alright, so the black hole we don't do for black hole. Servers, we did assign static IP address to the server. So we only need management, LAN, and VLAN. So after you've turned it on, just come here and write mgt pool mgt for management. Okay, and write the default gateway of the management network, which is 192.168.10.1, the first available IP address. Okay, our DNS server was that one, 37. Okay, good. Then we want it to start distributing IP address from 192.168.10.11 maybe. Subnet mask is 255.255.255.0. How many IP addresses do you want it to distribute? Maybe 200. Okay, and you say add. Okay, don't save, just say add. Okay, then we come back and modify this one, and you say this is now LAN. So LAN pool is 172.16.0.1, the default gateway. Okay, the DNS server remains the same. Then you want to start distributing from 172.16.0.11, no problem. Then subnet mask is class B. Okay, very simple. And how many IP addresses do you want it to give? So here, class B, actually we can say 1000. Okay, and we just add. Yes. So let me just confirm if everything is okay. Yeah, everything is okay. Then we finally go to VLAN. So when you come to VLAN, it's 10.20.0.1. Okay, the first available IP address VLAN. Yep, so 10.20. Yeah, it can start giving from .11. Okay, then you can also leave it that way. Then the most important part, remember, this is VLAN. And for VLAN, we have wireless LAN controller and the access points. So for this pool to work, then we have to integrate or link it to wireless LAN controller. We see here. Oh, we were supposed to say this one is VLAN. Yep. You see here, we have to put IP address of wireless LAN controller. So let's just assume the IP address of wireless LAN controller will be 10.0.10. Okay, then I'll just comment it here. Wireless LAN controller is 10.20.0.10. Good. Yep, then you just add. We're done with the DHCP server configuration. We're done with the DHCP server configuration on this topology. So let's see what's next so that we proceed. We need to configure OSPF on the firewall, routers, and the switches. Good. So as we said that we are not going to touch firewall as per now. We are only going to do OSPF on the routers and the multi-layer switches. Okay. So let's do it on the multi-layer switches first. So I click on the multi-layer switches. And we configure OSPF. So here we first check how many networks have been connected to this switch. Well, we had several networks. The one that we've done the interval routing for. So we try to hover over that. Just put your cursor over that switch. You can see for VLAN 10, VLAN 20, VLAN 50, and VLAN 90. We are going to advertise those 4 networks plus the first interfaces here up. There are 2 interfaces here, which is gig 11, having that IP address and that one. So in total, we are going to advertise 6 networks. Okay. All right. So so just say router OSPF 35. Okay. Then the route ID, very important. We will always do router as ID in everything we do. So route ID to be, this is the first one, so let's take 1.1. Okay, .1.1. Good. Then how many networks? We're going to advertise how many networks? 6 networks. The first network, let's advertise the one here above, okay, which is 10.2.2.0. Should I start notation? Wildcard mask 0.0.0.3 area 0. Then another network is this one. We just change it to 4 here. Okay. All right. So other 4 networks. Other 4 networks is for management, LAN, VLAN, and inside servers. Okay. Very simple. Very simple. So 1 and 2.168.10.0. 0.0.0.255 area 0. Other network is another network is 172 for LAN now. 172.16.0.0. Our wildcard mask is 0.0.255.255 area 0. Okay, LAN here. So let's move to VLAN. So VLAN is actually VLAN is 10.20 0.0. 10.20 0.0. Okay, /16. Do it there. Another network inside servers. So we just say network is 10.11.11.32. Okay. /24 notation is 0.0.0.224 minus 255. That becomes 31. Yep. Area 0. Exit and do right. So we've advertised how many networks? 4 networks. Do show start. So I want to copy the OSPF entries and paste to other switch, because 4 of the networks are similar, so I don't need to write them manually. So I copy those and I paste them there. Oh, sorry. Yep. So router SPF 35, that remains the same. Then the most important part, I repeat, the router ID should never be the same. 2.2. Delete this, just delete this. Okay. All right. So let's just close this one. And before that, there's some things that we need to verify. So the second switch, you can see it has a network of 2228 and 22212. So we just change this to 8, then that one to 12. Yep. But all of these remain the same. And just copy. Process ID can remain the same, but route ID should never remain the same. If you do that, then they won't form neighbors. They won't form adjacencies. Okay. All right. So I just paste there. Exit and do right. So they will form. It will form neighbors. This for this switch here. The due time. All right. So let's go to this router here. So on these routers, guys, I'll just demonstrate with one. Then the remaining two I'll do it very, very fast, save time. Because OSPF, we've been doing it for several times now. So what I ask you, you have to ensure that the IDs, the router's ID, are different. So here, let's say router OSPF 35, router ID to be 1.1.3.3, network to be 105.100.50.0.0.0.3, area 0. Another network is .4 here, this one, okay, area 0. Another network is 2020-2020, so we just make it 2020-2020, 20.20.20.0, exit and do that. So we are done with that router once and for all. We're done with it. We won't touch it again. Let's do the same here. Very, very fast, save time. Okay guys, so we've done OSPF configuration on the routers and the multi-layer switches. So that's done. As you can see, the last routers form neighbors with the two routers here, with the router ID. Very, very important. You have to give a unique routers IDs. Okay. Yeah. So actually, guys, we are now done with this. Now we can just cluster this again. So let me just put it here and mark it. Yep. Then we cluster it. Yep. So after clustering it, we can just say this one is now internet or cloud. Yep. Yep. So we are done with that. Good, 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 good. All right. So even this one, you can see it has formed neighbors with the other switches, with the other switch. All right. All right. So when you go back here, when you go back to configure it, now you're going to the firewall, the most important part in this topology, because if the firewall doesn't work, nothing will work. Okay. So before we go to the firewall, I just want to show OSPF and show IP OSPF neighbors. Yeah, as per now you can see only for VLAN 20, 10, 50 and 90. Good. All right, because it has not formed with the firewall, the firewalls are down. All right, good. All right, so guys, I think now it's a time that now we start configuring firewall. Okay, so when we start configuring firewall, actually the first thing that we're going to do is to ensure that we configure interface IP addresses. So as you can see here, number 9 tells us that firewall interface security zones and levels. Good. So being that this is a big lab, I don't want to take a lot of time here. I'm only going to demonstrate with one firewall, and on the other firewall, I'm going to do it a little bit faster so that we can save time. Okay. So I plead with you, please follow this video keenly, because if you miss something here, nothing is going to work. Firewall, if you miss something here, nothing is going to work. Good. So I'll just click on this firewall. We're going to do what's called interface IP address, security levels, and zones. Remember, in firewall, we normally have zones: inside zone, outside zone, and the DMZ. On this firewall here, we have the DMZ, the two inside zones. This interface connects inside, and any interface that connects to ISP is outside zone. Okay, so we have 2 inside zones, 2 outside zones, and 1 DMZ. Here, 2 inside zones, 2 outside zones. Good. All right, so let's do it. Well, the first thing I do, I'll just try to ensure that you take this top. Yeah. Ensure that you tick here so that when you click outside the pop-up, it doesn't disappear, right? Good. All right. So when I put it here, let's start with this file. We want to configure interface IP addresses, security levels, and zones. Good. So the first step, enable. Then you'll find here a password. By default, there's no password, just blank. The password is blank. Just hit enter. Config T. And let's give it a host name. Firewall 1. Yep, that's okay. All right, so let's start configuring interface IP addresses, security levels, and zones. So this interface, which you can see that connects to the first MAC layer switch, is gig 103, gig 1/3. So it's gig interface gig 1/3, and you hit enter. You can see it's still red, meaning it's in shutdown state. Just say no shut. Now it's up. Good. Then we assign it IP address. Okay. IP add, it's 10.2.2.2. Yes, 10.2.2.2, because .1 was taken by the interface of the MAC layer switch. Okay. All right. 255.255.252. Slash 30 notation. In firewall, please be very careful. All right. So that's the IP address there. Then there are 2 things that we need to do here: security level and zone. Okay. All right. So let's name it. Name if. Just give it a name if. Name if it's inside. So being that this firewall, we have 2 insides, inside 1 and inside 2. Let's just name it inside 1. Okay. Name if inside 1, and hit enter. Then security level, the zone is inside 1. Okay. The security level, now we trust everything on the inside. Okay. We don't trust anything on outside. We partially trust the DMZ. Okay. All right. So just give it 100%. 100. Good. All right. Then let's go to inside 2, which is this one. So inside 2 is gig 104, gig interface gig 1/4. No shut. Okay. Then I will give it IP address. You see here, this one, it's going to be in this network. This one, I believe it took this one, which is let me just show that switch. Yeah, you can see it took the gig 101 to 10.2.2.9. So this one will take 10.2.2.10. Okay. All right. So sorry. 10.2.2.10. Hit enter. The name is inside 2. Each interface should have a unique name. Okay. Inside 2 will have a security level of 100. We fully trust it. Okay. Good. Now let's go to DMZ. So the DMZ here, you can see it's gig 1.5. Sorry. The DMZ there will be gig 1.5. Okay. And then no shut. No shut. Then you give it a IP address. So when you come there, remember now this connects to the DMZ, and the network of the DMZ was 10.11.11.0/27. meaning this one will take 10, 11, 11, 1, okay, slash 2224. So I just come here and change this one, 10.11.11.1, okay. See this DMZ network here, slash 27, okay, and hit enter. Name if to be DMZ, okay. Security level will be, we can give it a value maybe 50, 70, more than 0 but less than 100. Okay, good, we're done there. Now let's go to the two outside zones. So on this firewall, we're not going to set up DMZ because there's no DMZ zone. Okay, on this firewall there's no DMZ zone. All right, so we're only going to set DMZ zone on this firewall. All right, so let's go to the other interface, which is gig 11 now. Interface gig 11, no shut. So then give it a IP address of 252. Then it's 105, 100, 105, 100, 50, 50 dot 2, because 50.1 was taken by the ISP. We said that the firewall will take the second user by IP address. Okay, it's only for the DMZ that it will take the first user by IP address. Okay, but any interface that connects to a layer 3 device, it will take the second user. Okay, all right, 105, 150.2. That's okay. Then name if to be outside 1. We have two outsides. Outside 1, security level 0%. Exit. Then let's go to the second interface, which is this one, gig 102. No shut. And then IP address, give it IP address. The IP address will become 197.200.100.2. 197.200.100.2, this network. Okay, good. Then name if outside 2 now. Okay, security level 0%. Exit and do write. So we're write memory. On the firewall, you don't say do write, we just say write memory. Okay, all right. So we've done IP address allocation on this firewall. So let's do the same on the other firewall. So it's very easy. Just be very careful. I repeat, firewall, you have to be very careful. If you're not careful, you'll have a lot of issues. Okay, so I'll do it very, very fast, save time. Okay, so guys, as you can see, we've done IP addressing on the firewalls. Okay, so we have assigned IP addresses to the firewall interfaces. We've given them a name or zones. Okay, and we've also given the security levels. Okay, all right. So by default, traffic cannot move from a lower security level to higher security level. Okay. Right. For example, by default, the firewall will block any traffic moving from the low security level, which is outside, to the inside zone. Okay. All right. So we're done IP addressing on the firewall. So the next thing that we're going to do is very simple. Let me check. Firewall inspection policies. Well, I will include something here. For example, 9.1. Okay. All right. Say firewall routing. Here we're going to configure OSPF plus static routes. Yep. So this is packet tracer firewall. We need to configure OSPF actually. If you don't want to configure so many static routes, then you can do just OSPF. Okay. All right. So we'll just do OSPF plus static routes. Okay. So for OSPF, each firewall will advertise the directly connected network. Okay. All right. So let's start with the default static route, because there's something I want to explain there. So when we start with the default static route, just say we're going to write two static routes. One is default static route, one is the backup. Okay, because we have two interfaces. So when one interface when one interface goes down, the backup static route will pick up. Okay. All right. So just do it this way. Let me just show you. Very simple. So we need to configure two static routes. One, the default static route. Another one is the backup of that static route. Okay. All right. So I'll just say IP route. Not actually, but route. Just a minute. Route. Yes. Route via. We want to use the outside zones. Okay. So let's start with the outside one. So it will be outside one. Outside one. Okay. Route outside one. Yes, let's query any IP address with any subnet mask. Okay. To go to inside one, which is inside one here. I just want to know, I mean outside one. Outside one, I believe is this one. So you have to be very, very careful. Let me just go up and see which interface is outside one. Outside one is gig 11. So gig 11 is this one, is the outside one. So any traffic that is routed out via outside one, okay, through outside one, and it matches this rule, any IP address, any subnet mask, then this traffic should be forwarded to the IP address of this router, which is 105.150.1. So it's 105.100.50.1. Yes, so this is the rule that we said. Route outside one, any network, any subnet mask to go to that IP address, which is the IP address of this router here. Okay. All right. So the backup of this route. Whenever this, let's say this interface goes down, let's configure its backup. So go to outside 2 now. Route via outside 2 interface, any IP address via any subnet mask to go this way. The IP address of this interface, which will be 197. It's 197.200.100.1. Okay. So to make it a backup route, we have to give it an administrative distance, which is higher than the normal static route. So a normal static route, I think it has an administrative distance of 1 or what? I'm not sure, but I forgot. Let me just say I've forgotten. But I'll just give this one administrative route of maybe 70. Okay. All right. So I just hit enter. Good. So we have two static routes. One is the primary, another one is the backup. Okay, the primary goes to CCOM ISP, the backup goes to the Safaricom ISP. All right, good. So let's configure OSPF here. Router OSPF, process ID of 35, then the router ID. Don't forget, I want to make it, let's say 1.1. Maybe 8.8. Good. Okay. Then the networks. How many networks will this with this firewall advertise? Let's start with the ISP. I mean the ISP network. So 105.100.50.0. Yeah. Then the subnet mask. In the firewall, we don't write wildcard mask. We just write the full subnet mask. Okay. 255.255.255.252. Area 0. Okay, and we just hit enter. Another network is 197.200. Okay, so we just modified this one to be 197.200.100. Okay, area 0. Sorry. Oops. Another network will be 197. You can see it has formed adjacency with the other router. 200.100.0. Yes, just hit enter. Yeah. So we've advertised this network and this network. Okay. All right. So we need to advertise three more actually. This one, and this one. Okay. All right. So let's start with this one. You see it's forming adjacency with the other routers or the multi-layer switches. All right. So another network will be that one will be 10.11.11.0. Okay. Then the solid mask will be 2224 because of /27 notation. Okay. All right. That's advertised. Then lastly, the two networks, this one and this one. So it's 220 and 228. Let me just do it very, very fast. So /30 notation, 220, 10.220, 10.2.2.0. That's one. Then 228. Good. Exit. All right, mem. Right, so you advertise all these networks on this firewall, and you can see it has formed all the adjacencies, all the 5 adjacencies. Okay. All right, so let's move to this firewall. I'll do it a little bit faster to save time. Just ensure you type top. Yep. Then we start advertising the networks. Remember, don't forget to configure default static route. The primary one, let it go to Safaricom. The secondary one to go to CCOM. Okay. So I start here. Let's check this each interface. This one, gig 102. Okay, so guys, as you can see, we have advertised all the networks on the 2 firewalls. Okay. All right, so I'll just write memory to save our config, right? Okay, so basically what I'm going to do next, you can see they have formed adjacencies with all the form layer 3 devices. Okay. All right, So the second thing that I'm going to do here is to configure firewall inspection policies. Okay. All right, which is very, very important. Actually, it's very, very important here. We need to configure firewall inspection policies to enable access to the resources which are outside of the DMZ. Okay, so we're going to do the inspection policies on the two firewalls. So we'll start with the first firewall. Okay, so I just click on this first firewall and we start configuring inspection policies. So before we can configure inspection policy, actually, we need to configure NAT. And to configure NAT, we need to create object networks. Okay, so let's create the object network. So we just say object network. We give it a name. Here, we are going to configure object network for any traffic from inside one. Actually, we have a lot of load here. We have a lot of load here. We have a lot of load here. So for NAT, I'm only going to do for LAN and VLAN. We don't want our management network to access internet, okay? Yeah. So NAT, we are only going to do for VLAN and LAN pools, okay? All right. Even our inside servers, they're not going to access the internet, okay? But the DMZ can access. So for NAT, we are going to create object network. So just follow what I'm doing. Object network from inside one to outside one first. Okay? Then here we're going to use which subnet? Here we're going to use subnet. We're going to use subnet of one for LAN first, okay? LAN. So let's use 172.16.0 255.255.0.0, okay? All right, so let's create NAT to be applied via inside one, comma, space, outside one, okay? To use dynamic interface. Let me query. There's nothing, just hit enter. Good. So that's one entry. We need to create a lot of entries. Okay, we need to create a lot of entries. So this one will only apply for the LAN network when it's from inside one to outside one. So let's create another one when it's from inside one to outside one. I mean from inside two to outside one. Okay, good. So just have to bear with me. Good. So the same one will apply there, same subnet. Okay, then for NAT, now it will be from inside two to outside one. Good. All right. So this one was for only LAN. So let's create another two. So let's create another two for VLAN. So for VLAN will be inside one to outside one. So they have to be unique actually. Inside one to outside one, but they have to be unique. Inside one, just give it W here for VLAN, okay? W there. The object name doesn't matter. All that matters is here when we're doing NAT. You have to specify that it's from inside one to outside one, okay? All right. So this one now, the subnet will be the VLAN 10.20. Hit enter. Then the NAT here will be applied via inside one to outside one. Exit. No, don't just exit. Let's just do inside 2 to outside 1. Inside VLAN 2 to outside 1. Good. So the subnet that applies here is just the same one. Then now here we include inside 2 to outside 1. Good. All right. So guys, we need to create more object networks, because the 4 that we just created will only apply from the 2 inside to inside 1 to outside 1. We've not created any that will apply from the 2 insides to outside 2, or even from the DMZ to the 2 outsides. Okay. All right. So I'll just do it very fast. The perimeter firewall, very technical, config T, a lot of work actually. So that's why we always need your support, because we're doing a lot of work for you, and we also expect to be appreciated here. We are going to create from inside 1 to outside 1 to outside 2 now. So object network from inside 1 to outside 2 now. From inside 2, from inside 1 to outside 2 now. Okay. Then this subnet should be used there. This subnet, okay. That subnet will be used there. Yeah. Then the NAT that will be applied is from inside 1 to outside 2 now. Yep. Then now let's get from inside 2 inside 1 to outside 2 for not actually, but sorry, inside 2 now to outside 2. Yeah. So just outside 2, inside 2 to outside 2 for this for still this subnet. Okay. All right. So for the same subnet. So now here will be inside 2 to outside 2. Good. All right. This one was only for this network, which is LAN. Now let's do for VLAN, so that the Wi-Fi users can access internet, right? Okay. So here I'm just going to do inside 1, inside W for VLAN, outside W for VLAN. Then the subnet that will apply there is this one. That's the subnet for VLAN. Okay. Then the NAT here now will be from inside 1 to outside 2. The NAT there will be inside 1 to outside 2. Good, for VLAN. Now again for from outside 2, inside 2 to outside 2, inside 2 to outside 2, same subnet. Now here will be inside 2 to outside 2. Okay, so we can choose to do for DMZ or just leave it, or we can just say object network DMZ to outside 1. Okay, the subnet here will be 10.11.11.0. okay, 255.255.255.224, and NAT will be applied between DMZ to outside 1. So this one, the DMZ is only on the one firewall. So the other firewall, we are not going to configure object network for DMZ. Okay. All right. So let's do for DMZ to outside 2. same subnet. Okay, then here the NAT will be from DMZ to outside 2. All right, right mem exit config t. So guys, we've done object networks plus NAT on the first firewall. So let's do the same on the second firewall. All right, it's very, very important that we do it. So if you don't want to do it manually, you just can say just do show start. In firewall there's no do, show start. Yep. So we just have to I just want to copy, sorry, I just want to copy these, actually these NAT entries. So I just want to copy these NAT entries. Yep. And I paste on the notepad. Then I'll let you know how we do it. For DMZ is not there. Just delete it. The DMZ is not there. The DMZ is not there. Good. Yep. So we just paste all these because on the two firewall we have both inside 1 and inside 2, outside 1 and outside 2, and we only want them to allow the two networks to access the internet. Okay, so we just copy paste this and paste on the other firewall. So it's very, very important that you be keen here, because if you're not keen, you're going to miss a lot of things. Yeah, good. So right mem exit config t. Good. So what's next? So when you come back here, we're supposed to do firewall inspection policies. Wow, very big lab actually. When it comes to firewall, you have to understand it deep. So let's now create inspection policies, okay, on the firewall. I just want to create create inspection policies to allow certain services or application. One is ICMP, ping. Another one is web, HTTP. The second one is the third one is maybe DNS. Okay, only let's just say 3. I don't want to allow too much because you can allow at your free time. I just want to demonstrate. Okay, all right. So when I come on this firewall, how do we create inspection policies? Remember, we've created NAT, and we've also done static routes. Okay, so let's just create inspection policy. We create inspection policies using access control list. So just say access list, access list, resource access. Just want to make it, I want to name it. It's a named extended, let's see. Yes, it's an extended, it's a named extended access control list. Okay, permit ICMP any. Yep, so this is for permitting ICMP from any network to any network. We're just going to do basic firewall configuration on this lab. If you start doing advanced firewall configuration on this lab, then it's going to take long. So I'll create another lab that is not big, but we will do advanced firewall inspection policy. Okay, all right. So let's now configure form. Let's now configure policy to access web. Web is port 80 HTTP. Okay, so ensure just press on arrow up, arrow down to retrieve the previous configuration and delete until somewhere there. Permit web uses TCP from any network to any network. TCP equals to port 80. That's for web. And just hit enter. Then now let's allow the DNS. DNS uses both DNS uses both DNS uses both TCP and UDP, port 53. So let's create another one for UDP. Just change this to UDP. So we've only allowed how many services? 3: ICMP, web, and DNS. But you can allow as much as you can. I just want to actually just to test. All right. Okay. So we've created the rules. We've created these rules here. Now, the only thing that is remaining is just to append them to an interface such that when that traffic reaches an interface, then the rules applies. Okay. All right. So how do we append them to an interface? Just say access group res. Okay. To get inside which interface? 3 actually. To get inside, we want to apply them to when someone is trying to access the DMZ or someone is trying to access the internet. Okay. So it's inside one, outside one, outside 2, and the DMZ. Okay, the 3 of them. DMZ. Another one is outside 1, outside 2. Good. That's all about inspection policies on that firewall. We are done configuring everything on that firewall. So let's move to the other firewall. Or what you can just do, it's very simple. Just say do show start. Then we just copy the inspection policies and paste on the other firewall. Yeah. Yep. So copy and we paste on the notepad. Paste here first, then change this to port 80, change this to DNS, port 53, port 53. Okay, we don't have DMZ on the second firewall, but we have inside 1 and inside 2. Good. So we just come here and we paste and write mem. Good. So it's just now a matter of testing if we can access, we can maybe ping this computer. Remember, we configured DHCP, but we didn't test. The DHCP was configured on this DHCP. So okay. So let's just try test using the computers first. I just want to test if it can receive. If you can't receive it, then I'm going to restart this packet tracer. Okay. All right. So let's just give it some time. Test again. If it doesn't work, it works. So you can see it works. Yep. So our DHCP is working. So I want to test if I can ping that network, which is 8.0.0.0. Let's just give it some time. If it works, then the firewall is working. We are done with the firewall. If it doesn't work, we will, there's nothing to look over again. We are done with the firewall. Done and dusted. As long as it can ping this network, or let's ping this computer, which is 80020. Okay, so it was this computer actually, 80020. As long as it can ping that network, then all is done. We don't need to worry about anything. Yep. So that's done. Then let's try to ping the DMZ devices. Let's try to ping even this one, 10, 11, 11, 11. Yep. So let's try to ping 10, 11, 11, 11. Where's that computer? Here. 10, 11, 11, 11. If it pings, the firewall is done and dusted. Okay. Now we move on to the wireless LAN controller. and the VoIP. The firewall is done and dusted. So we're done with the configuration from there to here. So the only configuration that is remaining here is the two guys here, actually. All right? Okay. So I would like to start with the wireless LAN controller. Okay, so to configure a wireless LAN controller, we will need a computer, maybe it to be in a management network, or we just connect it directly. Being that we don't have any computer connected to a management VLAN as for now, so what I'll do, I'll just include another PC here. I just include another PC here and name it as a NetSec PC. Okay. All right. So after naming it that way, I just connect it directly to wireless LAN controller. Then I configure it with the IP address that is in this range. Okay. So that they be in the same network. So I just give it IP address like that one. Maybe I can now give it maybe let's say .700, no problem. Okay, then this is a class B address. Default gateway, remember clearly, and then the net server remains the same, 37. Good. So after doing that, let's try to ping if we can get to ping the wireless LAN controller. Yeah, as long as you can ping it, then now we can go to the web browser and obtain the wireless LAN controller's console or the interface, okay, so that we can configure it. All right, so we just paste the IP address to the wireless LAN controller there, and we just hit enter. Then you have to give it some time because this is a wireless LAN controller on a Cisco Packet Tracer. It will take a couple of minutes. Okay, it normally hang, so that this is a packet tracer. You have to give it some time. Okay, so you see, it brings this window here where we need to create an admin account. So here we can create an admin account. Let's say our username is admin or Cisco. Just use Cisco caps. Then password to be Cisco caps, Cisco C caps at 1 2 3, Cisco the first letter caps at 1 2 3. You can create your own password, so doesn't matter as long as you remember your password. That's all we need. All right, so when you reach here, it asks you to fill in some fields here. So the first field is system name. System name, you can give it a device name. For example, use a Gurutech wireless LAN controller. And then management IP address, you remember very well, it should be the same IP address here. Okay. Subnet mask class B. Default gateway, you remember very well. All right. Then just click next. Leave management VLAN the way it is and click next. Here it asks you to create the first Wi-Fi name, Wi-Fi network SSID. So here, when you go back to our case study here, you can see clearly that we were asked to create employees, corporate auditors, and guest Wi-Fi networks. Okay, so that's what we're going to do here. So let's start with employees. Just name it hemp for the time being. I'll rename it later, or just give it full name. Employees. Yep. Then password, I'll just use Cisco at 1 2 3. Cisco at 1 2 3, and click next. Leave this the way it is. Click next. Confirm whether what you've written is correct, and after doing that, just save. Click apply. Well, it will disappear and come back later, so just give it some time. When it comes back later, just click OK and proceed again. So you have to give it some time. So actually don't wait until the saving configuration disappear. It will no longer leave this state. It will just be saving the configuration forever. Okay, so just close the web browser. Okay, come back to command prompt and try to ping. So remember the wireless LAN controller is saving the configuration that we just did, and it will reboot. So you can see it. The wireless LAN controller did reboot actually. So let's go back to web browser and access the wireless LAN controller now, so that we can configure the remaining Wi-Fi network. Yeah, so actually when you do that, you're going to get this error. When you try to write the IP address again and hit enter, you will write server reset connection. Just add HTTPS. Instead of HTTP, write HTTPS, okay? And hit enter. All right, so it asks you to log in. Password, our username was Cisco, then password was Cisco at 123, and just log in. Yep. So after logging in, we want to create how many networks? We want to create 4 employees, guests, auditors, and corporates actually. So to create Wi-Fi networks actually, or the first thing to do is to check how many. Remember, this is a wireless LAN controller, and we want it to control these access points. Okay. So for them to control, then for it to control them, they must synchronize. Okay. So just click on, go back to our config window and come back to wireless. Here you should be able to see the access points that have synchronized. So you can see we have how many access points that have synchronized: admin access point, ICT, HR, marketing, and finance. Okay, so now if you go to any access point and try to hover, just try to place your cover over the access points, you'd see they have an IP address. Okay, then the pop-up status is connected to the wireless LAN controller 10.20.0.10, and the providing VLANs. The VLANs are just the Wi-Fi networks that we've just created. We've only created one, which is employees. So let's create some 3 and come back there and check again, right? All right, so to create other VLANs, just come to VLAN and let me try to expand a little bit. Yep, expand it that way, and you can see these are our employees Wi-Fi name. Okay, so to create a new one, just click on go here. You see create new, just click on go and give it some time. So here we want to create that's called auditors. Okay, auditors Wi-Fi. Then the Wi-Fi will be just auditors. Okay, and click apply. So give it some time. Okay, so after doing that, after creating a VLAN by the name auditors Wi-Fi, a profile name the auditors Wi-Fi, and SSID auditors, just click enable so that the wireless network can be enabled. Okay, all right, so let's create password. The security keys, come to security here, and under layer 2 security, just choose this one. Okay, WP PA 2. Okay, all right, then take on WPA2 policy. All right, then also take on PSK. Then let's give a password here. Password we want to be Cisco at 123. Good, that's for auditors, and just click apply. Yep, so you can see it has applied. So just click apply again to save twice. Yeah, so this packet tracer in terms of wireless LAN controller, you have to be very careful. I mean, patient when configuring wireless LAN controller in Packet Tracer because it hangs. The window disappears, comes back again. So you have to be very, very patient. Yep, so that has been saved. So let's go and create 2 more wireless networks. So for that, I'll do it very, very fast because I believe you've seen how it's done. Or also, you can modify any wireless network here. For example, we want the profile name to be like auditors Wi-Fi, employees Wi-Fi. So just click on here, this one here, and you just modify the profile name. Then I come back and create the 2 other Wi-Fi network. Wi-Fi. Let the profile name to be that Wi-Fi, okay? And click apply. Okay, so let's create 2 more Wi-Fi VLANs. Okay, so I did very fast save time because I think you saw how I did the auditors Wi-Fi. Okay, so the last thing that you should do after creating all the required Wi-Fi networks is to minimize this thing first, that window, then save your packet tracer. Yep. So the reason why I'm doing that, the wireless LAN controller can sometimes hang and your packet tracer file is being terminated. So maybe you've done a lot of work, then the task is being terminated without saving, okay? Then after saving your file, just come to the wireless LAN controller and click save. Give it some time, it will disappear and come back later. Just click OK and give it some time. Yep, so everything has been saved. So let's verify if the wireless LAN control, the access points can actually display all the required Wi-Fi, okay? Wi-Fi name, okay? So I'll come back to the same. Yep, so I'll come back to the same access point, and you see we have how many Wi-Fi names: employees, auditor, corporate, and guest Wi-Fi. So guest Wi-Fi, the first thing you see, the first name you see, like employees Wi-Fi, that's a profile name. Then SSID, which is now the Wi-Fi name, is employees. Auditors Wi-Fi provides, auditors Wi-Fi provides auditor, corporate, etc., etc. Okay. Even this one you can see the same. Even this one the same. All right. All right. So what's remaining is just to connect the computers to the wireless network. Okay. So for example, let's test with this one. Come to config to wireless 0, and then here on the SSID, let's say this connects to corporate. Okay, then you come to WPA2 PSK. Okay, right, then password was Cisco at 123. So I copy and just close. So what I want to tell you is that it doesn't matter which access point it will connect to. Sometimes you will find this laptop here connects to an access point that is here. That's because it considers this access point to have highest strength. So it will only connect to an access point that has the highest strength. Okay. All right. So let me configure this to connect to auditors. So we see which access point it connect to. And the most important thing, don't forget to turn on the DHCP option on these wireless devices. As you can see, these devices, they have connected to the Wi-Fi, but they don't have IP address because the option is still static. Yeah, just turn it on to. We just come here and turn it on to DHCP. All right. So as you can see, although I've turned on the DHCP option, but all of these wireless devices, you can see they haven't picked the correct IP addressing. So the best option actually is always to save the configuration and close the packet tracer and open it again, because you can see all the access points, they have IP address, but the problem is the wireless devices. So I'll just turn it off and I'll save first, then I close it and open again, right? All right, guys. So I've restarted this packet tracer, and I believe when these access points will connect to the wireless LAN control, wireless access, I mean when these wireless devices will connect to the access points, they'll get the correct IP address. Okay. So meanwhile, let's finalize configuration of the VoIP. In this case, we have the final configuration is VoIP. So here we are going to configure this router, which is the Cisco voice gateway, to be our voice gateway actually. So okay, all right. So the first thing, let's go here, enable config T, and we enter this interface, which is interface FA00. So interface FA00, FA0/0, no shut. Okay. All right. So let's start configuring telephony service. So the first thing is to do. So the first thing we do actually interval routing. Okay. So just say interface FA0/0 dot. We create a sub interface for VLAN 70, VoIP post VLAN 70. Okay. All right. Then we give it IP address. IP address to be the VoIP IP address. You can see it was here. Yep. It was 172.20.30.0.1. 255.255.0.0. Okay. Okay, so before you assign IP address, actually, you have to associate it to a VLAN. Okay, you see 802.1q. So what you do, just say encapsulation .1q VLAN 70. Okay, and now you can assign it IP address. All right, and exit. All right, so the next thing is to create a DHCP for the IP phones. Okay, all right, let's do it that very fast. So the first thing, we just create we enable the service DHCP. Then we create pool IP DHCP pool. Let's say VoIP. Okay. Then the network, I believe you know the network is 172.30.0.0, 255.255.0.0. Okay. And then default router to be 172.30.0.1. Okay, then you give an option 150 IP to be the default route. Okay, 172.30.0.1. Good. Then we exit. All right. So with this, the IP phones will be able to get IP addresses. So we've configured interval routing plus DHCP server in the Cisco gateway so that the IP phones can get IP addresses. All right. So let's assign dial numbers. Okay. So now let's configure telephony service. So let's just enable telephony service. Telephony service. Good. Yeah. Then here now we specify the maximum number of earphones. Now just say max earphones to be. Let's assume we only need 30 phones. 30. Okay. Then the earphones must have directory numbers that equals to the number of, there must be directory numbers that's equal to the number of phones. Okay, max DN, which is the directory numbers. Then finally, not finally actually, but most importantly, we have to specify that IP source, okay, source address to be the IP address of the default router, which is this one. All right, 30.0.1. right? Then to use port, it's always 2000. Very simple. Then finally here, we just say outer assign from number 1 to number 30. Okay, then exit. All right, so let's start assigning. Just say we just say ephone directory number 1. Then we just give it a number. We just assign it a number. Okay, we just assign it a number. We were told that the IP phones should have numbers. I mean that dial numbers in which format? 400. Good. So we just say here number to be 401. Is it? The number 2, IP phone number 2 to have 42. So just do it that way. Okay, so that's all. Do right. Okay, so that's all about the configuration. So we just check the IP phones if they have any. Okay, so you can see the IP phones have got they have got actually the IP addresses. So they haven't taken. Okay, so so the IP phones haven't picked the dial numbers plus the default gateway. So we just need to restart this packet tracer and confirm that. Meanwhile, let's just go to the wireless devices and see if they have picked IP addresses. So you can see they have the correct IP addresses. Okay. All right. So what I'll do, I'll close this packet tracer again and open to see if the IP phones will pick the IP address plus the dial numbers. Okay. All right. So let's do it very fast, save time. Okay guys, so let's check. I've given it some 4 minutes. You can see now they have the correct IP address, gateway, and the line number, right? Every IP phone has the correct setting, right? All right. So let me try to ping or call from marketing department, okay, to maybe the last department, which is the ICT department. All right. So ICT department. Also, you can also see the ICT Yep. So the first one you can see. So just go to GUI. On this side GUI. Here you can see the line number is 44. Here 49. So I'm just going to try to call 409, and so you can see it's ringing. Okay, you can see from 44. Pick up and connected. Hang up. It's got hang up. So try to call 44. Okay. So same thing. 244. Okay, so that marks the end of this project. So if you want this packet tracer, please join the channel membership and send me a message via email or WhatsApp direct. I'll send this email to you direct. Okay. Alright. So please subscribe to this channel, like this video, share with friends, and please just write a comment on the comment section. Thank you so much, and let's meet again in project 14. Bye and see you.